Hi, I'm Jeff Ligon with RHIVOS, the Red Hat in-vehicle operating system. Today we're going to show you our demonstration of freedom from interference. We've got a car running around a racetrack, and we want to use the assisted driving, assisted steering process delivered via Quartz performance middleware being simulated in IPG CarMaker. This is a great demonstration of what we can do with Linux that is really new to the industry. So we have this freedom from interference approach where we have a Linux system running on this wonderful Qualcomm box. We're running the Red Hat in-vehicle operating system on top of it with an instance of systemd running on the root, and Podman has started a new container called the QM container. That QM container has its own systemd process inside of it so that it can start other processes that would no longer be able to impact any of the processes running on the root operating system. This allows us to separate untrusted and unsafe processes from safe processes. In our example, we have a safe process called ACC application, which is assisted cruise control. Some of you may be familiar with it. If it comes across a car in front of it, it will match the speed. So in order for us to demonstrate our freedom from interference, we want to be able to start processes inside the QM container and have them not impact the ACC process. In order for us to trust that we are free from interference when we're dealing with processes running inside the QM container, we want to make sure that we can actually fail the test first. Who trusts a test that doesn't go red before it goes green, right? So we're going to start a process inside the root of the operating system, inside the ASLB zone, that will peg the processor. And as we can see in the cycle time of the ADAS application, we're getting these spiky little bumps, and it's not as deterministic as it used to be. So now that we've successfully failed the test, we're going to start that same process, but this time inside the QM container. As we can see, the processor is going to be pegged again because we have full access to all 16 CPUs inside the Qualcomm box, and the cycle time of the application remains completely unchanged. We can really trust that we can run these workloads inside of the QM container without affecting safety critical decisions. That's the difference for the Red Hat in-vehicle operating system and why we're trying to change the way that operating systems are used today in automotive. To learn more about what we've shown today, please click the link in the description.